All right, we're moving on to section 9.5, special right triangles. You can make an argument that this section, along with the upcoming trig sections, are the most important sections in the entire curriculum this year. It's because you'll be doing a lot with this next year and the years that follow. So make sure you pay attention and make sure you get your questions answered as we go through this section. Okay, so let's jump right in and let's talk about 30, 60, 90 and 45, 45, 90 triangles. So if I have a right triangle and one of the angles is 30, which makes the other one 60 degrees, then the side that's opposite of the 30, we'll call that x. The side that's opposite of the 60 is related to that x in this way. It is x and then multiplied by the square root of 3. And the side that's the hypotenuse, the side opposite the right angle, is also related to the x in that it's just double the x, so 2 times x. So again, just to summarize, the side opposite the 30 is x, the side opposite the 60 is x root 3, and the side opposite of the 90 degree angle, or the hypotenuse, is 2x. So it's always going to be x, x root 3, 2x. For a 45, 45, 90 triangle, that means it's an isosceles right triangle, 45, 45, 90. Both of these sides will be called x. Obviously, they're going to be the same. This side, I mean, I could basically do x squared plus x squared equals y squared and solve for y. But this side is going to be x times the square root of 2, always. Okay, so if we're looking at 45, 45, 90, it's going to be x, x, x times the square root of 2. All right, so let's try some problems down at the bottom, and you'll see that this will come in handy big time. So if I look at this first one here, actually this first row, the side opposite the 30 is already given. But now, because I know the side opposite the 30, I can find the other two sides right away. The side opposite the 60 is going to be 4 root 3. And of course, the side opposite the 90, the hypotenuse, is going to be 2 times the x value, or it's going to be 8. This one, it's giving you that the hypotenuse is 12, so this is the 2x side. So you always want to try to find the x first if you can. The side opposite the 30 is the x. It's just going to be half of the 12, so it's going to be 6. And that means that this will be 6 times the square root of 3, because that's the side that's opposite of the 60 degree angle. So the next one, this is 30, and now, this is a little trickier. The side opposite the right angle, the hypotenuse, is going to be 18 root 3, so now I can find the x is going to be half of that, right? So it's going to be 9 root 3, and so now this one is going to be 9 root 3, that's my x value, times the square root of 3, because the side opposite the 60 is x times the square root of 3. Root 3 times root 3, we know it's just 3, so this side is going to be 27. All right, this is where it gets a little bit trickier. The side opposite the 60 is now 12. Now keep in mind that 12 is the x times the square root of 3 side. Now I can solve for x here, knowing that equation, given that equation. So x is equal to 12 divided by the square root of 3. Rationalize the denominator. So I'm going to get 12 root 3 over 3, or 4 root 3 is my x. That's going to be the side that's opposite of the 30 degree angle. And now the hypotenuse, we know, is just double that, so it's just going to be 8 times the square root of 3. Okay, so let's try some 45, 45, 90 triangle problems. So if this is 9, we know this has got to be 9. It's 45 degrees. The isosceles right triangle. And this side is going to be just simply 9 root 2. In this case, it's given that this side is 7 root 2, so I know that this is just 7 and 7, since this is x times the square root of 2, and these are my x's. And now this side is 14, so 14 is equal to x root 2. Solve for x is equal to 14 divided by root 2, or it's going to be 2 root 2, 7 root 2. So these will each be 7 root 2. Alright, let's try some problems on the backside. Okay, we're on the backside. Let's try some problems and apply the relationships, the 45, 45, 90, 30, 60, 90 relationships. So let's start with problem number 1 here. Find the altitude of an equilateral triangle. Here's an equilateral triangle with a side length of 2. So if I draw in an altitude like this, I know this is an angle that's a 60-degree angle there. This is 30. And I know that this is the side opposite. This is the hypotenuse. So the side opposite to 30 is going to be just 1, half of that. And then this side is going to be x root 3 or 1 root 3 or just root 3. Okay, the perimeter of a square is 48. Find the length of the diagonal. So here's a square. Looking for the diagonal. Let's call it x. Perimeter is 48, so that means that each side is 12. And this is going to be a 45, 45, 90 triangle, right triangle. So x is just going to be 12 root 2. That's the length of the diagonal. Let's jump down to number 4 here. Angle B is 30. BC is 10 root 3. Right angle here, right angle here. So I got some 30, 60, 90 triangles. This is the side opposite the right angle, so that means that this must be half of that. Okay, so it's going to be 5 root 3 because it's the side, it's the x side, the side that's opposite my 30-degree angle. And now if I just focus on this triangle over here, this is a 60-degree angle right there. The 60-degree angle is opposite of my 5 root 3 side. And so that means that this side is the side opposite the 30-degree angle, so that's my x side, so it's going to be 5. And this is my hypotenuse, so it's going to be 10. And did I get them all? Oh, BD. BD, if this is 5 root 3, then this is the side that's opposite of the 60-degree angle right here. And so that's going to be 5 root 3 is my x, and then multiply that by root 3. So it's going to be equal to 15. Okay, let's try this one down here. Diagonal of a square is 10. So there's 10. What's the perimeter? 45, 45, 90. And so these are x and x right there. So this is the side that's opposite. This is my x root 2 side. That's equal to 10. So that means x is equal to 10 divided by root 2. Rationalize the denominator. I get 10 root 2 over 2, or 5 root 2. So those are each my x's. And so the perimeter is just 4 times the 5 root 2, or 20 root 2. Okay, I'm going to stop here and let you try some problems on your own. All right, good luck.